Rebel King, the astronomer. So I'm looking here, I'm out in the field. It's early morning, June the 10th. And I can see the moon, and it's waning, and it's just past the half phase. So it was half phase yesterday. And so now I know what I'm looking at. I can describe the solar system as this. The sun describes the circumference of c squared in the distance of its travel over the year. It takes a year to go around the center of the solar system. And then you have the moon, which goes around the center of the solar system in a month. And then you have the center of the solar system, the matter that's around the center of the solar system goes around once a day. And then as you get closer to the center of the planet, you get something that orbits once every 2 pi times 10 to the minus 34 seconds when you measure it relative to the surface of the center of the solar system. So can you see the Earth? There's the center of the Earth. There's 0 time, which 0 energy point, which just about exists. It's the point of not existing, the center of the Earth. You come out to the sides of the Earth here, and you measure the time difference from there to there, and you'll see, if you took this as 1 second, just as a relative point up here, you measure everything relative to the 1 second of the surface, you're seeing the minus 34 here, and the plus 8 of the speed of light. When you add them together, it's 10 to the 42. And so ignore this real second. It's just our perception. You can take that away. It's not really important. What's important is the center and the 10 to the 42 meters, because that's the distance you can have in time. So this 10 to the minus 34 seconds, I'm going to call it 1 second. And then you can take everything relative from that then. So then you've got, in this 1 second of existence, you can travel, light can travel 10 to the 42 meters. And in so doing, it travels so far that it has momentum, and that momentum has a spin, has all the spins built into it. It's spinning on its east-west axis, and it spins so fast on its east-west axis, the light, a particle of light, let's say, it spins so fast on its east-west axis that it begins to rotate on the north-south axis. And once it's rotating on the north-south axis, the east-west axis spin becomes irrelevant, and everything becomes relative to the east-west axis. That's the strong force. And so what happens is it gets a right-hand curve because of the twist in it, and it bends that light. So there's a beam of light 10 to the 42 meters long, and it's got a bend in it of 137 arc seconds, the fine structure constant, the bending moment. And there's a bending moment at one end and a bending moment at the other. There's 2 bending moments because of this additional energy that the light has from its momentum, just from its velocity. It bends over that distance. You get 2 bending moments, one at either end. But then what happens is that the effect of both bending moments happens at this end, at the center of the solar system. So both bending moments are here. The strong force one, which is the lever arm of 10 to the 42 meters, with a force of a butterfly wing pushing it down this end, makes it just an enormous one on that end. But the effect of it is felt here. So you get the enormous effect and the butterfly effect at the center of the solar system. It's magic. And so what the center of the solar system looks like in terms of the light is a hemisphere called c squared, in E equals mc squared, funnily enough. C squared is the structure of light, and it describes the simplest relationship between 3 pi's. So you have to, it's a world of hemispheres, not spheres. Our clever brains construct the back of the moon, for example, to say that it exists. But this doesn't exist. It's a hemisphere of light. The back, from our perspective, doesn't exist. So c squared is a hemisphere of light, and it encapsulates the matter that exists at the center of the solar system as a hemisphere, and it rotates once a day around the planet. Oh, it's the planet. Around the planet. Light. And it lines up with the sun because it's the energy, the bending moment, and the energy setup puts the heat of the sun and the light of c squared in the same place, because one creates the other. The heat from the sun creates light. The light creates heat. That heat is expressed at the end of the 10 to the 42 because it's curled up on a spring. At the end of the 42, the sun, the heat from that sun is what the light gives off down here. It comes out up there. And so it's all just the day-night cycle is the c squared hemisphere of light rotating around the planet once every day, and it lines up with the sun. And when you see the moon, that's what you're seeing. It's the same effect. You're seeing c squared again. An image of c squared is projected at the other end of the bending moment. It's the moon, and that goes around once a month. So you can picture the c squared now. It goes in slow motion on the moon. You can see a hemisphere of light rotating. Okay? And there's an actual body there because it vibrates. It's zero frequency. It's zero energy frequency. It's what's happening at the center of the planet, and that's happening in the moon. And so I think it's got a dust coating on it. Because, yeah, I think it's got a dust coating on it. So there's a body there of vibration which has matter stuck on it, and then c squared is going around it. So it's a whole new solar system we've just built. It's the Veda cycle. It already exists. All of this already exists in all literature. The Veda cycle is correct. We just proved it now in science. So you're happy now that finally Galileo is speaking from the distant past and saying, my friends, we're back. The Earth is the center of reality. It is the center of the universe. It is the center of everything. Nothing exists but here, in this reality, in this universe. But are we alone? Is this the only reality? Are the galaxies and the binary stars and the fossilized lights that we see in the sky? What is it? What is it? In that motion that science says that it sees, what is that? Those binary stars that it sees, what is that? It's other realities. Is it? I don't know. I don't know. That's where we're at now, people. I've rushed you through to a moment of philosophical conjecture about aliens. And who are they and what are they? A whole new way of looking at it. Welcome to the future. It's going to be interesting, isn't it? A lot more interesting than Boris Johnson resigning. Love rules. Do the work. Choose.